So this video is going to be about the integration by parts rule, which I'm going to offer a simpler way of doing, which is called the DI or tabular method. So the integration by parts formula goes like this. The integral of u times dv, which is equivalent to uv minus integral of v du. And this is going to be your original integral, and you're going to try and reword it in a way that allows you to have the terms u and dv, which means the derivative of v, and you're going to try and get it into original u, and you'll get this v by integrating from dv, and this part is the integrated dv and the derivative of u. So essentially, we can do this using something called the DI method or the tabular method, which I prefer heavily over this. You won't be able to use it for everything, but for something simple like this, you definitely will be able to. So first, let's pull out that constant. So this is the same as 1 over pi times x cubed times cosine x dx, of course. And then I'm going to write the letters d, I, and I'm going to alternate signs at the side here, starting with plus, minus. So I'll get plus, minus, plus, minus, plus. And you can go on, but for now, I'll have this many. Now what we're going to do is I'm going to pick my term to be d for differentiated and I for integrated. So I know that when I differentiate x cubed, the power will decrease and eventually it will hit a x to the 0 term, meaning it turns into a constant and it can eventually go to 0. And I don't want my process to go on forever, so I'll pick x cubed. So you'll see what I mean in a second. I'm going to pick x cubed here, and I is cosine x. And essentially, this is u and this is dv, but we don't concern ourselves with that yet. So on this column, I'm going to go downwards like this, differentiating. Derivative of x cubed, 3x squared, 6x, 6, and then 0, right? It goes to 0. Cosine x, we're going to be integrating, which means we're going to find the value that is differentiated to give you cosine x. That would be sine x. Then we need the value that is differentiated to give you sine x. Cosine x differentiated will give you negative sine x, so we need negative cosine x to cancel it out. Then we would need negative sine x. And then it would loop back around to cosine x. So the way that this loops back around after 4 cycles, with the cosine and sine switching into each other and then the negatives rotating out, this is pretty important for some other questions where you'll find that you have the same term on both sides and you can cancel or solve algebraically for the value of your original derivative. So I'll explain that later, maybe in a different video. But for now, what we're going to do, you're just going to have to remember this. You're going to draw arrows downwards. Down 1, and to the right. So diagonally, like this. Until it hits 0, because 0 times anything would be 0. Then, the answer to this derivative is going to be positive x cubed times sine x. So I'm going to write this down here. x cubed sine x. And then minus 3x squared times negative cosine x, which makes it a positive. So it's plus 3x squared cosine x plus 6x times negative sine x, so minus 6x sine x. And then finally, minus 6 cosine x. Of course, don't forget plus c. And at the beginning, we pulled out 1 over pi as our constant, so let's put that back. And that's the answer. Sorry, this plus c should be up here. But yeah, the way this works is it's actually the same as plugging and chugging into this this integration by parts formula, except this is a bit more visual and I find it's easier to understand. So the times when this won't work and you'll have to do something a bit different is, for example, when you have 2 cyclic functions. I'm going to call them cyclic. I don't know the proper term. So for example, e to the x and sine x. If you were to try, doesn't matter which one you pick, d or I, these ones would cycle around forever because e to the x won't ever go to 0 or won't ever, well, yeah. And integrating sine x and then negative cosine x and so on, neither of these will hit 0. So instead, you'll see the point where it hits 4, and you'll take that value and you'll plug it back into this number here as your result from the integral, and you'll somehow be able to cancel something out to find the true value of your original integral. And that's integration by parts with the DI, or also known as tabular method.